All right. Test 14, Form B. This is your review. Hopefully, we've got at least a fair amount of this done. Question number 1. Amy was driving M miles to Atlanta at V miles per hour and arrived 3 hours late for the race. Let me see if I can do this at least, so there's something to show up on this video. Let's pull up. Hopefully, it's in here somewhere. Review 14. And go back and forth between this. There we go. It's not that it's great, but it is there. All right. So this is a distance, rate, and time question. Okay, what does it list for my distance? M. Okay. Let's see. Do we have a rate or time? We have a rate. Okay, it gives me a rate is V, correct? So what am I going to write for time? Because distance equals rate times time. Rate equals distance over time. Time equals distance over rate. So they're only ever going to list two things for me. Whenever I get to the third, I need to show it as a ratio. So we're going to have M over V plus 3. Okay, does that make sense? All right. Now, the final question is, how fast should she have driven to have arrived on time? So if we're talking about how fast, what are we using? Are we using distance, rate, or time? Rate. Okay, so we're going to have a new rate, which is new distance over new time. Am I changing the distance at all? No. Okay, it's still just M, but I am changing time, correct? All right, what should my time change be? M over V minus 3. And I'm going to set that as M over V minus 3 over 1 because we're going to solve the denominator down. So I'm getting M over M minus 3V over V. And because essentially that's M over 1 divided by M minus 3V over V, I'm going to end up multiplying by the reciprocal. I can look at it like this, where I have M over 1 times V over M minus 3V. So it should give me MV over M minus 3V. And that should be in miles per hour. Okay. Does that make sense? I know it looks like a board full of stuff, but it's really shouldn't be too terribly difficult to do that question. Right? We should be getting used to distance, rate, and time. Okay? All right. Question number 2. Let me go back to page here. Buddha and 10 of his students sat around a circular table. That ought to be a big hint for us what we're going to need to do there. How many seating arrangements were possible? All right, so how many people are there? No. There's 11. But we're only because it's a circular table, what am I using? Does anybody remember what we do here?
It's 10 factorial. Well,
It's 10.
Factorial.
No, it's 10. You're right. It's 10 factorial because it's a circular table. Position really doesn't matter. So one person's going to sit down.
But Buddha.
Yeah, I know. Right. Once one person sits down, that sets the stage for everything else. So the first person sitting really doesn't change anything. It's always, when we're talking about a circular table, we're going to take the number of people that there are, subtract 1, and do the factorial for that. Okay? So we should have 10 factorial, which is a pretty large number, right? What is it? 3,628,800.
So I have a question that why do we subtract the 1?
Okay, so remember, if you remember when we talked about like King Arthur and his 4 knights, right? So let's say we've got 1, 2, 3, 4, 5 people. Well, once King Arthur sits down, now it's a factorial. So essentially what is happening is it's 1 times, in this case, 5 times 4 times 3 times 2 times 1. So because that 1 doesn't matter, it's not that it doesn't exist, it's just that it's not going to change the outcome. Okay? So, I mean, if you want to consider, it's really 1 times 10 factorial. All right, does that help you out at all? Okay. All right, number 3, Ben flew a distance of 480 miles at a moderate speed on the trip back, which was also 480 miles. Ben doubled the speed of the plane. How fast did Ben fly? On the trip back, if the total traveling time was 6 hours, okay, there is, I guess, kind of a complicated way of doing this, or we could do this really easily. Okay, if he's flying 480 miles, but he's doubling his speed of the plane, how fast did Ben fly on a trip back? All right, if the total traveling time was 6 hours. So if he's doubling his speed, he's cutting his time in half, right? So kind of consider that, you're essentially taking 6 and dividing it into thirds, right? So what's 6 divided by 3? Okay, equals 2. So if we want to know, let's see, how fast did Ben fly on the trip back? Okay, he's flying 480 miles in 2 hours. So 480 miles over 2 hours. On the way back, he's flying 240 miles per hour. Does that make sense? Now the hard part there is to get the 2. Okay, do we understand why we got 2 there? Okay. Hopefully. If it helps, he's cutting his time in half. He's cutting it in half because he's doubling his speed, right? So he's going to cut his time in half, right? All right, consider you're going down the interstate, it's 60 miles. Your typical speed is 60 miles per hour. If I cut my time in half, I would have to travel at 120 miles per hour, right, to cut the time in half, right? So as I'm doubling my speed, I'm cutting my time in half, which means if it's 6 hours, that means it was 4 hours one way, 2 hours back, right? I still have to come up with a total of 6 hours. Does that make sense? Okay. So, if you imagine that as 6 hours, here's 2, 2, and 2. This is the trip back. This was the trip there. Okay. All right. Let's see. So that's number 3. You should have gotten 240 miles per hour. How many distinguishable permutations can be formed by the letters in the word sassy? All right. So you're going to take the number of letters that you have and put that on the top with factorial. How many letters do I have in the word sassy? 5. All right, and we're going to put that over letters that repeat factorial. So what letter repeats? S, and how many times does it repeat? 3, so that's that right there. So 5 factorial over 3 factorial. You're going to plug that in your calculator and tell me what you get for an answer. Did anybody already have an answer for this? I had a bunch of people raise their hand and say that they got the review done. So what was your answer, Liz? Okay, you did it wrong. Did anybody do it this way? No? Okay, we ought to have our calculators out and ought to be trying. If you don't have a calculator, make sure you get it out or borrow one. Okay, make sure you guys know how to do this. 20. The answer should be 20. Okay? Let's just erase this. All right, complete the square. All right. So how do I go about completing the square with something like x squared minus 4x plus 2? What's your first step? Subtract 2. So I should be writing up x squared minus 4x, leaving an empty space and putting minus 2 as I move that 2 over. What's the next step? not just 4, but negative 4. It doesn't ultimately end up changing it, but yes. What's negative 4 divided by 2? Negative 2. All right, what's negative 2 squared? Positive 4. All right, so we're going to put positive 4 here, positive 4 here. All right, because this is being recorded, and hopefully you guys are taking notes for sake of space, I'm going to erase that there. This point, we want to find the factorial, or find the factored form of x squared minus 4x plus 4. What do I get there?
X minus 2 is minus 2.
Right, so it'd be x minus 2 squared equals what?
Oh, 6. No, 2.
Okay, x minus 2 squared equals 2. Okay, in order to solve this, I'm going to square root both sides, and because I'm square rooting the left-hand side to find the right-hand side, this is going to be plus or minus the square root of 2. Okay, this is going to be x minus 2, right? What do I want to do with that 2 there? Okay, right now I have x minus 2 equals the positive or negative square root of 2. Add 2. All right, so I should be getting x equals 2 plus or minus the square root of 2. Let me see my answer here. What are they looking for? It says complete the square. Oh, to graph it? Okay. So I think what they ultimately are coming down with is what they are looking for in order to graph this is the vertex formula, which would be y equals x minus 2 squared minus radical 2. They would bring that back over. That's the vertex formula of that, which means I'm going to go to the right 2. I'm going to go down radical 2. That's going to be my vertex. Because this is positive right here, it's going to open upwards. Okay? Actually, let me take that back here for a second, because we square rooted this based upon that. This would just, hold on a second. We got y equals x minus 2 squared. That was negative 2. So let's see. We would end up adding 2 there. So that's our vertex form of it. Oh, hold on. No, because that's positive 2. We would subtract it. It's basically Monday. Okay, so that's our vertex form of it. We're going to go right 2, down 2. Okay. And then we would graph that going upwards. Does that make sense now? I am so sorry that I've bungled that, but it should look like that. All right. All right. Number 6. Anybody get an answer for this? Okay, we got an answer of 3. Anybody else get an answer here? We got. I heard 4. Who got 4? Liz had 4. Okay. All right. So we got several different little things going on here. 4 is the right answer. Okay. Did you get 4?
I got 3.
Got 3. You should get 2 possible answers here. One is negative 8. The other is 4. Okay. So let's start off with what should we do first in all of this? What's your first step? Move the 2 to the exponent of every term, right? All right, so you got 3 squared plus natural log 2 squared equals natural log x plus 2 squared. Is that right? Correct? Yes? Okay. Can we go ahead and find out what those things would be once we've squared them? What is ln 3 squared? 9. ln 4, right? And what about x plus 2 squared? X squared plus 4x plus 4. Okay? Now, all those natural logs, do they all have the same base? Yes? Okay? As I drop off the natural logs, what's going to happen with that addition? It's going to become multiplication, right? So what's 9 times 4? So we're saying that 36 equals x squared plus 4x plus 4. What would you do with that 36? What's that? Subtract it. Okay, so we're going to subtract 36. All right, I'm going to switch colors here. So we've got x squared plus 4x. What's 4 minus 36? Negative 32. So then we are factoring that down. So we've got x and x. If it's plus minus, then it's really got to be plus minus, right? Okay. All right. Let's see. X plus 4 minus 8. That's not going to give me a positive 4 there, though. Plus 8 minus 4. Okay, which means x equals negative 8 or x equals positive 4. Okay, as we look at this, though, right, can it be negative 8? Can I substitute negative 8 in there? No, because that would cause my natural log to be a negative number. I can't get that, so it has to be x equals 4. Do we know what kind of mistakes we made doing that? You just added the 8, and so you added 9 plus 4 and got 13, right? Did you FOIL?
Yeah, total.
Foiled, but forgot to change it to multiplication. Ryan, do you know what you did differently?
I just dropped the natural logs off and added 3 plus 2 is equal to x plus 2.
Okay. So there was maybe a few things there that went wrong. Okay. All right. Hopefully we understand where to go from here now, right? Okay. Dylan, try to stay up here with me, okay? All right. Let's see, number 7. Anybody get an answer for number 7? You got 2 over 9? Sorry, 10 over 9? Okay, 10 over 9. Anybody get anything else? Got 1.
I already know my way wrong.
What'd you get?
1/3.
Okay. Nobody else got an answer? Vanessa, you showed me that you had it done. What did you get for an answer? Well, let's see. What? Wasn't sure about it. JP, you had yours done. What answer did you get? You got 1. Okay. All right. So we've got log base 6, but 1 doesn't have a log base 6, right? So can I drop off the logs? No, I can't drop off the logs. So I have to, I've got to put this in ratio form. Okay, so we're going to get log 9x over log 6, right? For the left hand, and then I'm going to do right minus. Oh, I've got to move this guy up here, right? So what is 3 squared? 9. So I'm going to write log 9 over log 6 equals 1. Okay? How many of you remember to start that way? Dylan, you got a question?
Yeah, isn't it 9x? Or like, wait, what happened?
This one is 9x, right? But this one's just 9. Okay? Because 3 squared is 9.
Oh, okay, I see what you're
Okay.
doing.
Now, I can rewrite this as kind of like one thing. You know, if we do it like this, we can rewrite this as really just this, correct? Right. Now, what do I want to do with that log 6 in the denominator position? Multiply it. So I'm going to put it over here, right? Right. Whenever I do that, now I can get rid of this. All right. What do I want to do with that 1 in front of the log 6? move it to become the exponent. Is that going to change the value of it at all? No. So what I'm seeing then is I have log 9x minus log 9 equals log 6. Is the base the same in each of them now? Okay, what happens, I see subtraction between log 9x minus log 9. What happens whenever I drop that log off? And so I'm going to rewrite it as 9x over 9 equals 6, right? Okay, so what do I do with the 9? Multiply it. All right, so I've got 9x equals what? 54. Divide by 9, x equals 6. Yeah, you could cancel out the 9s. Yep. So, yeah, you could do that, but I just wanted to take it step by step through. Okay? Just because not in every case will it work out perfectly where I'm going to cancel out. Okay, so we all understand at least up to number 7 so far? Okay. Let's see, let's get to number 8. The wheels of the party van have a diameter of 2 feet. We want to probably perk up and see that that's diameter and are revolving at 2,000 radians per minute. What is the linear velocity of the party van in inches per second? So when we're talking about this, we want to make sure we know our formula is linear velocity equals radius times angular velocity. Okay, so V equals omega R. Okay. So we've got 2,000 radians per minute, and we've got a diameter of 2 feet. We need to convert our 2 feet into a radius. So what's the radius there? 1 foot. And since we're wanting it in inches per second, could I go ahead and convert that just to 12 inches? Okay. All right. So what I have here is V equals 2,000 radians per minute. Okay. We've got our 2 feet, which we're going to divide by 2. Right. We're going to show the conversion there just so we don't lose anything. Right. We've got 1 foot. It's 12 inches. And because we want this in per second, we're in minutes, right? We're going to put our minutes up here because our minutes are down there. We're going to put our seconds down here. 1 minute is 60 seconds. So we're going to take 2,000 times 2 times 12 divided by 2 times 60. 48,000 over. So yeah, I got 48,000 over what? 120? Okay, what does that reduce to?
24,000. Wait, no.
Nope. 48,000 divided by 120. 400. Comes out to 400, and I want it in inches per second. 400 inches per second is our linear velocity. Okay. Do we have that down? Hopefully we're taking notes, especially a bunch of us that didn't get it done, forgot to do it.
Wait a second. Aren't I the one that did it?
No, you're not. No, I'm not singling you out. Okay. 9. We want to write 6,900 as 10 raised to a power. Okay, how do we go about doing that? Okay, so we want Ln 6,900. What does that equal?
8.8312.
Then what we actually ended up doing is we solved for B. Okay, in order to find 6,900 as 10 raised to a power, I believe you want to do log, try log 6900. Right, 3.8389. Okay, because that's going to be 10. Okay, so what would happen is if I change this to exponential form, I would get 10 to the 3.8389 equals 6900. So my answer here is actually 10 to the 3.8389. That's the answer there for A. Okay, so what you did for A is what was what you actually want to do with B. We want to write 69 as e raised to a power, then we have to find natural log of 6900. Okay, so our work for that is ln 6900 equals, and what do you get? You got 8.8393. Is that right? Okay, so your answer is e to the 8.393. 8.8393. This is your answer. Okay, so that's what it needs to look like. Don't just give me 8.8393. Okay, show it, because that's what it's wanting to see. Write e raised to a power. Okay, does that make sense? Okay, so log to get your exponent, natural log to get your exponent, make sure that you finish it. Right? All right, 10. Okay, we want to let, we've got f of x equals radical x, g of x is radical x plus 4. Which of the following statements is true? A, the graph of g is the graph of f translated 4 units to the right. Okay, B, the graph of g is the graph of f translated 4 units to the left. C, the graph of g is the graph of f translated 4 units up. And D, the graph of g is the graph of f translated 4 units down. Which do we think is correct? C. That's it. Okay. If this had been, how would we have showed this translated 4 units to the right? What would g have to have been? All under, right? Right, that would have been 4 units to the right. Does that make sense? If we wanted to translate it 4 units to the left, we would have had that, right? If we wanted to translate it 4 units down, we would have done x minus 4 like that, right? Okay. So just so you're aware of how to change that and manipulate that graph. Okay. Let's see, number 11. Travis had D kindred who worked T hours to get M number of drums made. The key, or then K kindred left. How many hours would it take the remaining kindred to make R drums? What is my equation that we're using here? Anybody? We have to know what equation to use first. R times W times T equals jobs. I think that's what you were trying to say. Okay, so rate times workers times time equals jobs. All right, we never knew our rate to start with. How many workers do I have to start with? What did you say? D. Okay, D. Okay, how much time is being used to start with? T. Okay, how many jobs are getting done? M. All right, so what is my rate? M over dt. Okay, so we've got M over dt. Okay, and let's see. Now K kindred left. So what am I going to write for my workers? D minus K. Okay, we don't know our T, but how many jobs are we trying to get done? R. Okay, so up here I've got M times D minus K over dt. times t equals r. My face is trying to sneeze. I'm trying not to let it. All right, so what do we do at this point?
Multiply the dt
Multiply the dt.
to the r.
Okay. And then what?
Multiply the reciprocal.
Multiply r by the reciprocal, right? Okay. So just as if it was this. Okay. So I should get r dt over m times d minus k. Make sure that matches with my answer. R dt over m. And you could distribute the m if you want. I'm not going to count off if you have r dt over md minus km. Okay. All right, that should be our answer there. And that is probably going to be a good place to stop for today. I'll probably end up finishing this video with the other class. All right, so look for both of these videos to get probably uploaded by about halfway through the day. Okay, you guys will have in class tomorrow to study. Okay, I highly recommend that you do.